Hello, I'm Byung Kim. We present our work, Online Continual Learning for Interactive Instruction Following Agents. Interactive instruction following agent, also referred to as embodied instruction following, requires task completion via accurate navigation, object interaction, and interactive reasoning. To learn these embodied instruction following agents, we usually take three stages: collect training episodes, train the agent, and deploy the training agent. But what if we have some new tasks? How do we learn this new one? A straightforward approach is to include the training samples of the new task in the training set and train the agent again. In this case, the agent may perform both previous and current tasks well, but retraining from scratch can be slow and costly. To avoid this heavy computational cost, we can just fine-tune the agent only to the new task. Here, we learn only the current task, not the previous ones. In this case, the training process might be efficient and fast, but fine-tuned agent can lose their knowledge of previous tasks, called catastrophic forgetting. Then how can we effectively and efficiently learn new tasks while maintaining previous task knowledge? For this, we propose a continual learning setup for embodied instruction following agents called CL Alfred, which extends the recently proposed Alfred benchmark. Specifically, our proposed setup includes two incremental learning setups: behavior incremental learning and environment incremental learning setups. In each setup, the agent is required to continually learn new types of behaviors or environments, such that the agent can perform both previously learned and newly encountered behaviors or environments. One way to continually learn new tasks is to expand models for every task to prevent overfitting to the current task while mitigating catastrophic forgetting. However, memory cost increases proportional to the number of tasks, which can be substantial. To prevent heavy memory cost, another approach maintains the output logis of previously learned models and learns previous knowledge from these logis via knowledge distillation, which can save much memory space. However, once obtained, these logis are fixed, and if they come from insufficiently learned models, they may harm learning previous tasks. To address this issue, recent work updates the logis every end of a task to maintain accurate information of previous tasks and can improve the logis in part. However, we still have several issues here. First, this assumes that explicit task boundaries are available, but these may not be always available in more realistic scenarios, such as continuously changing data distribution. In addition, because the logis are seldom updated, the logis may still be insufficiently learned, hampering anytime inference performance. To address these issues, we want to use logis from sufficiently learned models and continuously update them during training. Here, we observe that the confidence scores of logis for the ground truth classes can serve as a good indicator of how accurate the obtained logis are. Motivated by this, we propose a simple yet effective approach, confidence-aware moving average. We weight sum the previously and currently obtained logis using exponential moving average, whose weight decay factors are dynamically determined by the recent confidence scores. The key intuition is that we put more weights on the current logis if they have higher confidence scores, implying higher accuracies, and vice versa. We validate our approach in our proposed setup and observe that our proposed approach outperforms previous methods with noticeable margins. We also conduct a qualitative analysis. Here, we evaluate how well an agent performs in the previously learned environment, bedrooms. We observe that a naive baseline fine-tuning and the best performing prior work takes up irrelevant actions and eventually fail. In contrast, our approach can successfully complete the task, implying that it preserves knowledge of the previous learned environment. In summary, we propose a continual learning setup CL Alfred for embodied AI agents, and we propose a simple yet effective method of confidence-aware moving average to address the proposed setup. Thank you for your attention.